this is another tutorial on Calculus 2. So we have decided to do most of the sample questions from the University of Nairobi question paper. So most of the concepts we have uploaded video by video showing on how to evaluate most of the integrals. So straight away I'll just use the concepts that we have uploaded, solve some integrals as we continue to make clarity and familiarity with calculus questions. So straight away there's a question that says calculate the following integrals. Okay, so the question is calculate the following integrals. So number one, so the first question, okay, we are told the integral of x squared, okay, divided by x squared divided by into bracket 4 minus x squared, close the bracket, raised to 3 over 2, okay, dx. So this is the question we are told to evaluate. So straight away, as you can see, we'll start by try to see what the integral is. Okay, as you can see here, it's being raised to 3 over 2. So this is just the same as the square root of this, okay, raised to power 3. So I'll just split the integral and I'll write it as the integral of x squared divided by, so this 2 usually becomes the square root, so it will be the square root of 4 minus x squared, 4 minus x squared, then the whole thing, it's raised to power 3, okay? The whole thing is raised to power 3. Okay, this is what it means. So this is what it means. So at dx, sorry. So from there, as you can see, okay, we are told, as you can see, this is the square root of 4 minus x squared, okay? So in my video, we talked of trigonometric integrals, okay, trigonometric substitution. So as you can see, this resembles a trigonometric substitution, okay? This part, the square root of 4 minus, it resembles trigonometric substitution, of which in our trigonometric substitution, we wrote our formula as, so this, when it's minus, it represents trigonometric substitution for sine, okay? Usually say the integral of the integral of dx, okay, let me just write. Usually say the integral of the square root of a squared minus x squared dx. When you're given an integral of something like this is the one of the trigonometric substitution formula for sine. We usually told you choose your x to be a sine of theta, okay? So as you can see, this part resembles this part, okay? So from there, we just continue, So we'll write, I will have to choose my x to be sine of theta, okay? So when I choose my x to be sine of theta, I'll say, let's find our a, of which a squared is just 4, x squared is just x squared, right? So I will say my a squared equals to 4. So I'll get my a as the square root of 4 plus or minus, but I'll just take the absolute value 2, okay? Then I'll say x squared equals to x squared, so it's just x squared, right? So this is my a. So substituting my x, I'll place my 2 here, okay? So I'll get my x to be, what's the value of a? 2 sine theta, right? So we have expressed x in terms of sine of theta. So I'll find my x squared. As you can see there's x squared. So I'll find my x squared. It will be square this, it will be 4. Square this, it will be sine squared of theta, right? So from there, I just have to substitute all this information we have gotten. Okay, sorry, again here, there's a dx here. So I chose my x to be that, so I'll just choose again. I'll just differentiate x to get my dx. We're trying to manipulate those. So I'll get my dx as differentiating x with respect to theta. I'll get just 2. I'll just write equals to 2. Okay. Differentiating sine, I usually get my cos theta. Okay. But it's with respect to theta, so it will be d theta, right? So from there, just replace all the information inside the integral. Okay. So I'll just clear this and replace my information inside. As you can see, there is a. Keep in mind that a. Don't forget. So I'll clear this again. So I'll write the integral of x squared. Okay. But what is my x squared? It's 4 sine squared of theta, right? Okay. I'll divide by, what's my, okay, I'll divide by this 4. I'll divide by the square root of 4 minus, what's my x squared? It's that is just that 4 sine squared of theta, okay? But all these expression, it's being multiplied by, it's being cubed, okay? So from there, don't forget the cubed dx. What's my dx? I'll multiply by dx. What's my dx? My dx is that. So it will be 2 cos of theta d of theta, right? So as you can see, the procedure is very simple. So we can just clear this. The procedure is simple like that. So from there, let's factor out 4 inside. So let's factor out 4. So I'll get my integral of 4 sine squared of theta multiplied by that 2 cos of theta d theta. I will divide it by the square root. So I'll factor 4 outside here. I'll get the rad. The rad remains of 4 into, okay, 4 into 1 minus sine squared of theta, right? 1 minus sine squared of theta, close my bracket, and that whole thing, it's being cubed. Don't forget that part. So I'll get my square root for 4, and I'll get my this other square root. So I'll get the integral of 4 sine squared of theta multiplied by 2 cos of theta d theta, okay, divided by the square root of 4 is 2, so it's 2 multiplied by the square root of this, okay, multiplied by the square root of 1 minus sine squared of theta, but the whole thing is being cubed, okay? So just continue with the same procedure and just again clear the upside. Continue. So from there, so what is 1 minus sine squared of theta? Okay, in my previous videos we said, what's the Pythagorean identity? The Pythagorean identity here we use is 1 plus tan squared of theta equals to this is sine, sorry. This is another, okay. Let me just write for clarity, secant square of theta, but we won't be using it, that's just a Pythagorean identity. There's another Pythagorean identity for sine. Usually sine square of theta plus cos square of theta equals to 1, okay? So when I move my sine squared to the other side, I'll get my sine squared 1 minus sine squared of theta as to be my cos squared of theta, right? So I'll replace all these expressions with cos squared of theta, okay? So I'll get the integral of 4 sine squared of theta multiplied by 2 cos theta d theta divided by 2 multiplied by the square root of, okay, so it will be 2 multiplied by the square root of, we said all these expressions, we replace it by cos squared of theta. So it will be cos squared of theta, and again don't forget to cube, okay? So from there, let me just clear here. So as you can see, how to solve the process is just procedural, and it's simple using the concepts of trigonometric substitution. You can check out my video. I have given out all the formulas on trigonometric substitution. So from there, we'll get the integral of 4 sine squared of theta multiplied by 2 cos theta d theta divided by, what's the square root of cos squared of theta? It's just this power 2 cancels with the square root, so it will just be cos of theta. So it will just be 2 cos of theta, right? Don't forget to cube that. So let's cube, okay? So we'll say the integral of 4 sine squared of theta multiplied by 2 cos of theta d theta divided by 2 cubed is 8, okay? Cos cubed is just cos cubed theta, right? So there's a 1 cos here, so I'll just cancel 1 cos. I'll be remaining with my 2 coses. So my 4 goes here 1, my 4 goes here 2, my 2 goes here 1, my 2 goes here 1, right? I'll be remaining with the integral of sine squared of theta, okay? Sine squared of theta is what I'll be remaining with, d theta, okay? Divided by, here I'll remain with cos squared of theta, right? Cos squared of theta, something like that. So as you can see, we have narrowed down the integral to this point, okay? So from there, I will say there's a reciprocal identity also. I made a video on reciprocal identity. I said when you are given what's my tan, I said my tan theta as a reciprocal identity is just sine of theta divided by cos of theta, right? But now I can square my tan. I'll have to square here and I'll have to square here. So as you can see from here, sine squared, cos squared. So I'll just replace all this information with tan, okay? So I'll just replace all that information with tan. So the procedure is very simple, but kind of long. So I'll get the integral of, instead of me writing sine squared divided by cos squared, I'll write tan squared, right? I'll just write my tan squared of theta. d theta, right? So that's what I'll be writing. But what is sine squared of theta d theta? Okay, what is tangent squared of theta? Okay, from there I can use my reduction formula for tan. Okay, my reduction, I had made a video again on reduction formulas of tan. Formula for tan to any power but for this case, since we don't, okay, it's just another tiresome process when finding the reduction formulas for tan. So I'll just use another method. I'll just replace tan squared of theta with the Pythagorean identity. We had already wrote the Pythagorean identity as we already wrote the Pythagorean identity. So we say 1 plus tan squared of theta is just the same as secant squared of theta, right? So what's my tan squared of theta alone? I'll just take my 1 the other side. I'll get secant squared minus theta, right? So I'll just get my tan squared of theta is the same as secant squared of theta. Simple. Minus 1. Okay? So this is what I'll be replacing again inside there. Okay? So I'll write the integral of secant squared of theta minus 1. Don't forget to place the theta. Okay? It's becoming interesting. So from there, it's simple. When I'm integrating 1 with respect to theta, it's just theta, okay? When I integrate secant of theta, I already wrote the formulas, is just tan of theta, cause I can try to explain that from this point. When I'm told to find the dy dx of tan theta, my answer, also my dy dx of tan theta, is just secant squared of theta, right? But now, for me to get back, I'll just have to integrate. So when I integrate secant squared of theta, it's just tan of theta, okay? So I'll just be simple like that. As you can see, so the integral of secant squared of theta is just tan of theta minus, I'm integrating 1 with respect to theta, so just theta plus a constant c, okay? But that won't be my answer. That's still not my answer. So we said you can perform this using the reduction formula, but it's kind of long because you. Okay, so from here we said we have already integrated that, but okay, this is literally our answer. Yes, this is just our answer, but we won't leave it in terms of tan and theta. So we'll have to manipulate this again. So remember back in your mind, we said our x is the same as 2 sine of theta, right? This was our first conclusion. So from here, we'll have to draw a triangle using SOHCAHTOA. Okay? Using SOHCAHTOA, we draw our triangle. So what is sine of theta? So let me just draw the triangle. Okay, the intuitive explanation for this is our answer. This is our supposed answer, but we'll have to replace tan of theta with the variable, tangent theta alone with the variable. So let me choose my theta to be that. So from here, I'll say my sine theta. Sine theta is opposite. What is my opposite from this triangle? This is the opposite. Opposite is x. Okay? Divided by my hypotenuse. So when I divide by 2, I'll get my hypotenuse as 2. Okay? So what will be my adjacent? We usually say using the Pythagorean theorem, we usually say 2 squared minus x squared equals to b squared, right? So what's 2 squared? 2 squared is just 4. So what will be my b? My b will be the square root of 4 minus x squared, right? So my b here will be square root of 4 minus x squared, okay? So my b will be the square root of 4 minus x squared, right? But let's now find our tangent theta. So our tan theta from there, tan theta, as you can see, it's opposite x, okay? Divided by adjacent, the square. What's my adjacent here? The square root of 4 minus x squared, right? Okay, so from here, my final answer will be, here's my final answer. What's my tan theta? My tan theta is that. So my tan theta is x divided by the square root of 4 minus x squared minus, okay, minus, this minus, but what is my theta? My theta alone, I will get it from here. From here is where I get my theta. So x divided by 2 is sine theta. So sine theta is the same as x divided by 2, x divided by 2, okay? So my theta alone is arc sine of that thing. So it's just the same as sine inverse of x over 2, right? So that's my theta. So I'll replace my theta. So I'll be minusing sine inverse of x over 2, right? Then from there, just close the bracket and I'll place my constant c. So that's our answer. So this is the solution to that question. As you can see, the solution is long, but it's explainable using the concept of trigonometric substitution. We'll reach here, and when you reach here, as you can see, it's quite easily done. So these are answers. So these are first example from the University of Nairobi using trigonometric substitution. Okay. So my next video, the example, this is example 1. Remember. So my second example will be dealing on different concept. Following, I'll be posting a sequentially video solving some of the integrals in calculus 2. So don't forget to like, share, subscribe. It's Lee Prof from the University of Nairobi. Thank you. My WhatsApp number, sorry, it's 0. It's okay. Let me just write the standard way. So my WhatsApp number. You can reach me through my WhatsApp number, you will get most of the questions. So my WhatsApp number is that. So that's my WhatsApp number. You can reach me through that. You'll get most of the questions on. Okay? So that's my number. Sorry, this is 9. I'll be posting most of the questions. Okay, so more comments on the comment section. How when you have a trouble reaching here, you can reach me through my comment section. Thank you. I'll be uploading the next video.